and I'm going to pull up the all exam formula sheet. Notes. Okay. And also, this was from 8.2. And as far as the formula sheets are concerned, these formulas are not on the formula sheet. We kind of talked about these. The sine is y over r. And keep in mind, this is in reference to the unit circle where the radius is 1, right? So in order to find the sine of some angle, we'll simply locate that angle. The y coordinate will be the sine. The cosine is the x coordinate. And then the other 4 trig functions can be found by these relationships. Now, if you have a triangle, let's say it's hanging out in space, and what I mean by that is it's not on an x and a y axis, there are a different set of formulas that we're going to use. So what we're going to do today is basically solve some right triangles. And in order to solve a right triangle, you basically find all of the angle measures and you find all of the side lengths. But in this last section, our triangles, for example, number 5, it's not on an x and a y axis. Okay, it's just sort of hanging out in space. If you're dealing with right triangles that are not in an x and a y axis, here are the 6 trig functions. Okay. And we use this little slogan. It's called Chief SOHCAHTOA. I don't even know how many people have heard of that. Anybody heard of that before? Chief SOHCAHTOA. Is another one that says Oscar had a heap of apples. Anybody have heard that one? Let me just write these down. These are mnemonic devices to help remember these things. Oscar had a heap of apples. All right, so what this means is the sine of some angle is the opposite over the hypotenuse. So that's what it is in Chief SOHCAHTOA. So you're going to hear me say this a lot. The psi part alludes to the fact that the sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. And the tangent is the opposite side over the adjacent side. So the Oscar had a heap of apples is the same. That O and H, the opposite over the hypotenuse, that's the sine. A heap, that's the cosine, which is the adjacent over the hypotenuse. And then of apples, that's the tangent, which is the opposite over the adjacent. And it's another one that this guy told me. He was a student. And this was funny when he told me to me. He said some old hippie caught another hippie tripping on acid. He said that's how he remembered. I don't know where he got this from. I don't know if he made this up, but some old hippie, that's the sine is the opposite over the hypotenuse. Called another hippie, that's the cosine is the adjacent over the hypotenuse. Tripping on acid is the tangent, is the opposite of the adjacent. But I'm going to stick to Chief SOHCAHTOA. All right, so we're actually going to do a couple of these or a few of these problems in class. Now, one thing I have noticed, this is like I'm doing a statistics class, and then when I come from, and it's right in the same classroom, and then when I do the trig class, I have to like get adjusted to going from statistics to trig. So I'm noticing that for some of the problems, they ask you to round to like 4 decimal places. So this thing says use a calculator to find the length of each side to 4 decimal places. If it says decimal places, you can use your calculator. But there's other problems that don't say anything about decimal places. So if it doesn't say anything about decimal places, that means they want the exact answer. So we're going to do this in a couple of parts. We're going to start with the ones that want you to write the answer in the decimal form, and then we'll move to the problems that want the exact answer. So the first problem we're going to do is number 7. Right, and it asks us to round to 4 decimal places, right? So in order to solve a right triangle, it basically means to find all of the angle measures and all of the side lengths. But here they only want us, they give us an angle measure and they give us a side length. They just want us to find the other 2 side lengths. All right, so before we actually do that, there's something called standard labeling, right? And they use this standard labeling throughout the course. For standard labeling, and this is my right triangle, capital letters are angle measures. Capital letters are angle measures. Okay. So I'm going to call this angle A, angle B, and angle C. Normally, not all the time, but normally C is your right angle. Okay, so notice all of these are capital letters. Because on some of these problems, they'll show you a triangle, and on other problems, they'll just give you the dimensions without showing the triangle. So when you're given the dimensions without showing the triangle, they're using what's called standard labeling. So for standard labeling, capital letters are your angle measures, and normally C is your right angle. The lowercase letters are side lengths. So lowercase letters are side lengths. Okay. So for angle A, the side that's opposite angle A is side length A, and that's a lowercase letter. So this is what I mean by opposite side. So this is my angle A. The side that's opposite angle A is side length A. This is angle B. The side opposite angle B is side length B, and that's with a lowercase b. And here we have angle C. The side opposite angle C is side length C, and that's a lowercase c. So if you're not given a triangle, the triangle is using standard labeling. All right. So for our first problem, we're given a triangle. Okay. So notice they don't really give us the angle measure spelled out. They just give us B, right? So this is angle B. This side is opposite angle B. That is side B. This is side A. The angle opposite side A is angle A. They didn't label angle A. And then this would be angle C, right? The side opposite angle C is side C, which is the hypotenuse, and the hypotenuse is A. All right? So we're asked to find A, and we're asked to find B. So first we're going to find angle A. Whenever you're asked to find the dimensions of a triangle, right, I could find this angle like if I wanted to, right, angle B. How many degrees are in a triangle? 180. So this is probably going to be important. There are, and this is just a fact, or facts, the hypotenuse is always the longest side in a right triangle. Right? The hypotenuse is always the longest side in your right triangle. There are a total of 180 degrees in any triangle. That doesn't matter if it's a right triangle or a acute triangle. The fact that there is 180 degrees in every triangle. Okay, now this is from geometry. It's probably been a while since you took a geometry course, but this is the formula for sum of interior angles, and it's n minus 2 times 180 degrees. That's supposed to be 180 degrees, and n is equal to the number of sides. Okay. So like if you're dealing with a triangle has 3 sides. 3 minus 2 is 1. 1 times 180 is 180. If you have a square has 4 sides. 4 minus 2 is 2. 2 times 180 is 360 degrees. There are a total of 360 degrees in every square. So if you're dealing with a pentagon, hexagon, whatever you're dealing with, this is the formula that would give you the sum of the interior angles. So since we're strictly dealing with triangles, the fact remains that the total of the angles in any triangle should be 180 degrees. So just by knowing that, I could actually find angle B, right? This is 90. This is 11 degrees. So whatever angle B is, it would have to, I could just take 180 minus 90 minus 11, and that would give me angle B. Right? But they didn't really ask us to find angle B, but we could find it, right? So I'm going to actually map this out. So. That was B11, and that's 8. Because I'm going to have to draw on this. So this is number 7. That's my 90-degree angle. This was 8. This was B. This was 11 degrees. So I'm going to just go ahead and label this out. Okay. So just based on what they gave us, this was angle B, that's side length B. They gave us A. So this is angle A. And then by process of elimination, this is angle C. So this is side length C. So this is how I can find B. So I want to find angle B. Even though they don't ask us to find B, I'm going to find B. So angle B, so that's just a mathematical symbol for angle. That's equal to 180 degrees, because there should be a total of 180 degrees in any triangle, minus the sum of the other two angles. So what I'm really doing is I'm taking 90 and 11, I'm adding those up, and then I'm subtracting from 100. So 90 plus 11 is, what is that, 101? And then 180 minus 101 is what? 79 degrees. So that's only if you had to find angle B. All right, so I could also find all of the side lengths using the Pythagorean theorem, right? C squared is equal to A squared plus B squared, but I don't know A or B. There's too many unknown variables, right? So I have to set up a trig function. Whenever you set up a trig function, so now we're going to find A. When you set up a trig function, you want to use Chief-Sakatoa. And remember that when you're setting up your trig function, there should be only one unknown. So when you set up a trig function, you want to use Chief-Sakatoa, and you have to establish a reference angle. Right, so now we talked about a reference angle, and a reference angle is basically an acute angle. So you never use the 90-degree angle as your reference angle. In this case, I'm going to use my reference angle as the 11-degree angle. So normally, you want to make sure that you know your reference degree angle if at all possible. So I'm putting this little curvature just to denote that this is my reference angle, and I'm going to use Chief-Sakatoa based on that reference angle. So when I say Chief-Sakatoa, that means we got to label our sides. We have to label one side as the hypotenuse. So the hypotenuse is always opposite the right angle, right? So I generally like to label the hypotenuse first. So side C, which is across from the right angle, that's my hypotenuse. Then I like to label the opposite side. So if this is my reference angle, angle A, the side that's opposite my reference angle, that's my opposite side. So the opposite side is side A. So side A is opposite to angle A. So that's my opposite side. And then my adjacent side is side B. So now adjacent means side by side. So like this is 1005. The room over there is 1004. These rooms are adjacent because they share that common side, that common wall. Angle A and side B are adjacent because they share this common side. So I have the opposite, the hypotenuse, and I have the adjacent label, right? And that's all according to my reference angle. Because I could choose B as a reference angle, but that would change up my opposite adjacent. So what trig function, right, the chief Sakator, could I use to find side A? Well, let's take into account what we know. So A is the only thing that I don't know, which is the opposite. But I know the hypotenuse and I know my angle measure. So if I have an opposite and a hypotenuse, I can set up what kind of trig function? The sine, right? Because the sine is the opposite over the hypotenuse. So I'm going to set this up as the sine of 11 degrees. That's equal to the opposite, which is side A, over the hypotenuse, which is 8. Right? So that's my trig function. And I can just solve this for A. So how will I solve it for A? Well, the first thing I would do is get rid of the fraction. So whatever you do to one side, you got to do the same thing to the other side. So I would multiply both sides by 8. So I'm going to multiply. So I'm going to clear the fraction. And I'm going to multiply both sides by 8, right? So I'm going to multiply the left-hand side by 8. I'm going to multiply the right-hand side by 8. And once I multiply the right-hand side by 8, the 8s are going to do what? Cancel. So 8 times the sine of 11 degrees is equal to 8. So I'm going to evaluate that in my calculator. So I got to be careful with the calculator because whenever you use one of these trig functions, sine, cosine, or tangent, you have to be mindful of the mode. So what should the mode of my calculator be? Should I be in radian mode or degree mode? Degree mode because I'm given an angle measure in degrees. So I'm in the right mode. And I'm going to just put that in. 8 times the sine of 11 degrees. And I get 1.5. So 1. Oh, 4 decimal places. 1.5265. 1.5265 is equal to A. All right, so that's side length A. So next we're asked to find any questions about A. Right, so next we're asked to find B, side length B. Okay. Now I can set up another trig function to find B. Or I could use the Pythagorean theorem since I know side B and I know side C. I can use Pythagorean theorem, or I could set up another trig function. Normally you want to set up, you only want to set up one trig function as possible. So I'm going to use Pythagorean theorem. So here are all of the different variations. C squared is equal to A squared plus B squared. So we have C is equal to the square root of A squared plus B squared. B is equal to the square root of C squared minus A squared. A is equal to the square root of C squared minus B squared. So same form as we were using X, Y, and R, but now we're kind of reverting back to C, A, and B. So I can use this formula to find B. So B is equal to the square root of C squared minus A squared. So C was 8 squared minus, and this is where you got to avoid rounding error. Because if I use this number, right, 1.5265, I rounded that at the 4th decimal place. And if I use that in the calculation and round that, that may cause some rounding. So what I want to do is, since they want the final answer to be rounded to the 4th decimal place, I'm actually just going to go a few decimal places over, just so I can avoid that rounded error in that 4th decimal place. So I'm going to go over to, I guess, the 6th. So that's 1.5264719 or something like that. So this is the square root of 8 squared minus So let me explain what I did by this answer thing. Answer is above the negative key and is yellow. The answer would be the very last result. So that 1.526471936, whatever that is, keep on going. That's answer without rounding. So the little trick to doing that is, whatever your last line of output was, answer is storing. So that's the square root of 8 squared minus at 1.5265 squared, and we get 7.853. 7.853. Okay. All right, so A was 1.5265 and B was 7.853. All right, any questions about number 7?
How did you get the answer for A?
This 1.5265?
I'm talking about like
Say that again now?
So how did you find A squared? Like when you found B, how did you get A squared?
Oh, I didn't actually use, I used C and I used B to find it. So let me go back. So like right here, well, yeah, we found A in this previous result right here. Let me go, okay. Yeah. So we had set up this trig function to find side A. So we use that sine function. And then when I found B, I used that previous result from A. So on my calculator, this little answer, it actually stored that A value. Answer is always that very last line of output. That's where that's stored, if you want to recall. All right, so any other questions about 7? Okay, now let's look at the first one. Well, I guess number 3. All right, so I'm kind of looking at the answers at number 3. I'm in a little cheat thing with teacher's preview. But if you notice, so for question 3, it doesn't say anything about a decimal answer or rounding to 4 decimals. Since it doesn't say anything about rounding to 4 decimals, we have to use the exact value. So that means if there's a square root in the answer, they want to see the square root. So the calculator is only going to give us a decimal answer, no square roots whatsoever. So let's take a look at number 3. And also for number 3, they don't give us a triangle. They simply give us the dimensions, right? Side A is equal to 3, and and angle A is 30 degrees. So let me write that down real quick. A is equal to 3, and angle A is 30 degrees. So I'm going to sketch this one out. So number 3, A is equal to 3, angle A is 30 degrees. Now, it really doesn't matter what angle physically on this triangle you call A or B. Okay, so I'm basically going to start at the top. I'm going to call that angle A. I'm going to call this angle B. This is angle C. The side that's opposite angle A is side A, and that's 3. The side that's opposite angle B is side B. The side that's opposite angle C is side C. And they also give us that angle A is 30 degrees. And we're asked to find B and C. So let's find B. All right, so I can't actually find B by using the Pythagorean theorem because there's too many unknowns. So that means we have to set up a trig function. Chief soccer told. In order to set up a trig function, we must establish a reference angle. In this case, I'm going to establish angle A as the reference angle. I'm going to label my sides according to that reference angle. So first, I'm going to start with the hypotenuse, right? So the hypotenuse is always opposite the right angle, so that is side C. Angle A is my reference angle, so side length A is opposite. So side A is opposite to angle A. So that's my opposite side. And side B is going to be my adjacent side. Right? So I have my opposite, adjacent, and I have my hypotenuse labeled according to the reference angle. Now, if we want to find angle B, or excuse me, side B, what trig function must we set up? Well, let's take a look at what information we have. All right, well, we're trying to find side B, and that's the adjacent, so we have to include the adjacent as part of our trig function. We know the hypotenuse, and we know the angle measure. So if I have the adjacent and the hypotenuse, what type of trig function could we set up? Cosine, right? Because the cosine is the adjacent over the hypotenuse. So I'm going to set that up as the cosine of 30 degrees. That's equal to the adjacent, which is B, over, well, can I use a cosine? I'm going to just write this down. Well, I don't think I can use a cosine because I got too many unknown functions, right? I mean, I don't know B and I don't know C. I have to use B, but I know A, which is what? I mean, I know side A, which is the what? Opposite. So the adjacent and the opposite is going to give me what kind of function? Tangent function. So this is where you got to be careful. When you set up your trig function, there can only be one unknown. So if I were to use a cosine, I got too many unknowns. Right? So we're going to use a tangent function. Okay. Too many unknowns. So we're going to say the tangent of 30 degrees, that's equal to the opposite, which is what? 3 over the adjacent, which is B, right? So now I want to solve it for B. So what should we do first? Well, I got to get rid of the fraction. So I want to multiply both sides by B. All right, so I'm going to multiply the left-hand side by B. I'm going to multiply the right-hand side by B. On the right-hand side, the B's cancel. So B times the tangent of 30 degrees is equal to 3. So now how do I solve for B? Well, the opposite of multiplying by B times the tangent of 30 degrees is to do what? Divide by the tangent of 30 degrees. So let me just put that step in. Divide both sides by the tangent of 30 degrees. All right, so on the left-hand side, the tangent of 30 degrees cancel. So B is equal to 3 divided by the tangent of 30 degrees. So now, since it doesn't want me to use my calculator for the decimal answer, where could I find the tangent of 30 degrees, the exact value? We can find that in, I'm going to go back to the formula sheet section and that unit circle function value chart. Right. The tangent of 30 degrees is going to be the square root of 3 over 3. So if I were to put that in my calculator, it's definitely going to give me a decimal. Oh, all right, so B is equal to 3 divided by the square root of 3 over 3, right? So this is how I'm going to simplify this. Okay. So I have, this is for a complex fraction, simplify a complex fraction. A over B all over C over D. That's equal to A times D over B times C. All right, so I'm going to rewrite this as 3 over 1 divided by the square root of 3 over 3. So what I'm doing is I have my main fractional bar. So this is the formula to simplify a complex fraction. A complex fraction is just the main fraction bar with a fraction in the numerator and a fraction in the denominator. So I could multiply the very top and the very bottom. So I can multiply 3 times 3, and that'll go in the numerator. I can multiply the bottom of the top and the top of the bottom, so I can multiply 1 times the square root of 3. Does everybody understand where I got this from? 9 divided by the square root of 3. I took 3, and I just wrote that as a fraction. 3 divided by 1, just to make that a fraction, so I could use the formula. And I took my denominator, I kept it the same, square root of 3 over 3. I can multiply the very top and the very bottom. So that's the A times D, and that goes in the numerator. I can multiply the bottom of the top and the top of the bottom. So 1 times square root of 3 is square root of 3. You have to make sure when you're dealing with radicals that the denominator is rationalized. So that means there should not be a radical in the denominator. So does anybody remember what we can do to rationalize the denominator? And this is what you're going to run into sometimes. So we got to rationalize the denominator. So we got to multiply the top multiply the rationalize the denominator. So we got to multiply the numerator and the denominator by the denominator. Okay. And this is probably going back to intermediate algebra. Probably been a while. So I'm going to take 9 divided by the square root of 3, and I'm going to multiply that by the square root of 3 over the square root of 3. So anything over itself is 1, right? So the square root of 3 divided by the square root of 3, that's just a 1 in disguise. So whenever I multiply anything by 1, I don't change the value, but I can change the way it's written. So now I'm going to multiply my numerators and multiply my denominators. Whenever you multiply fractions, multiply the numerators, multiply the denominators. So if I multiply my numerators, 9 times the square root of 3 is just 9 times the square root of 3. If I multiply my denominators, the square root of 3 times the square root of 3 gives me what? The square root of 9 and the square root of 9 is what? 3. Right? So anytime you multiply square roots, you can just multiply the radicands. 3 times 3 is 9. Or the square root and the square cancel, which is going to give me 3. I just want to show you how this breaks down. Now I'm going to simplify. So this 3 in the denominator is going to reduce only the 9 down, right? 9 divided by 3 gives me what? 3. So this simplifies down to give us 3 square root of 3. Now, these 3's don't cancel because this is a 3. And this is the square root of 3, which is like 1 point something. So I can't cancel the square root of 3 and 3, but I can reduce 9 and 3. And this is what makes it long and drawn out if you. They don't want you to use the decimal. You got to do some rationalizing denominators and that sort of things. But b, side length b should equal to 3 times the square root of 3. All right. So if we go back, b should be, and that's where they get 3 square root of 3 from. And we set up the trig function. We pulled out the tangent of 30 from the unit circle function of values, and we simplified. Now we're asked to find side A. All right. So I'm going back to the top. What trig function could I set up to find side Is it A or is it C? Oh, to find C. I'm sorry. Okay, because they give us A. Okay. All right. So what trig function could I set up to find C? Well, I got to use the hypotenuse because that's what I'm trying to find. I know the opposite, and I know my angle measure. So an opposite and a hypotenuse would give us what type of function? From chief SOHCAHTOA, the sine is the opposite over the hypotenuse. So I'm going to use a sine function to find C. So the sine of 30 degrees, that's equal to the opposite, which is 3, divided by the hypotenuse, which is C, that's unknown. Right. So then I will multiply both sides by C, then divide both sides by the sine of 30. So C is equal to 3 divided by the sine of 30. I skipped some steps, but is everybody okay with it? I multiply both sides by C. So C's cancel, and then I divide it by the sine of 30. So we're going to do the same thing. I'm going to look at that unit circle functions of values and find the sine of 30, and then we're going to simplify. All right, so C is equal to 3 divided by, and if we locate 30 degrees, the sine of 30 degrees is 1/2, so we don't have to worry about the radical thing. So I'm going to substitute 30 with 1/2. And I'm going to do the same thing. So I'm going to make that 3 over 1. Right? So I'm just changing 3 to a fraction. 3 over 1. Divided by, and then my denominator is a fraction. So I'm going to multiply the very top and the very bottom. So 3 times 2 is 6. I'm going to multiply the top of the bottom and the bottom of the top. So C should equal to 6. So B is equal to 3 square root of 3. And C is equal to 6. So any questions about number 3? So in the questions, if they ask you to use or to write your answer as a decimal, right, you can use a calculator, but if they don't say anything about a decimal, you have to use the exact value. And using that unit circle function of values. Let's see, I'm going to scroll down. We'll take a look at the last problem. Number 14. And it talks about an angle of elevation to the top of a building. It's found to be 7 degrees from the ground at a distance of 2 miles. So on some of these things, you got to be careful because here they give us the unit is miles. Then it says find the height of the building to the nearest foot. So they're giving us a dimension in miles, but they want the final answer in feet. So there's going to be some conversion at the end of 14. Now they didn't pop up in 13, and they gave us feet. Yeah, they gave us feet, and they wanted to know how many feet in the answer. But notice carefully here, they're giving us miles, but they want the final answer in feet. So here's what an angle of elevation is. And then we'll take a look at the problem. You have an angle of elevation and you have an angle of depression. Right. For each one of these angles, you must have a horizontal. So that's like that horizontal ray, sort of like, I guess you would think of it as standard position where all of the angles start along that positive x-axis, that horizontal. So you have to have a horizontal. The angle of elevation is here. So if you think about it as a person, that's a funny looking person, but if that's the person's eyesight, my eyesight would be level and an angle of elevation would be looking up from that horizontal. And then you have angle of depression. The angle of depression, you have a horizontal, but you are looking down. That doesn't mean that the angle is negative or anything. That's just mean that you're looking down. And that's supposed to be a person. All right. So we're talking about angle, and these are supposed to be straight lines. So we're looking at this setup, an angle of elevation. So we have a horizontal, and then we're looking up. And this is the angle of elevation. All right, so it says an angle of elevation to the top of a building is found to be 7 degrees. Let me just write this down. And it says from the ground to the distance of 2 miles from the base of the building. Okay. And that's the building. Find the height of the building to the nearest foot. All right, so this is number 14. Right, so we have our horizontal, and that's 2 miles. We have our angle of elevation, which is 7 degrees. And then we have our building over here. Put some windows on it. And we want to find the height of the building. So that's going to form a right angle. So it says the angle of elevation is like 2 miles from the base of the building. So this distance is 2 miles. The angle of elevation is 7 degrees. And they want us to find the height of the building. So we got to set up a trig function. Right, I can't find the height because I don't know all three sides of the right triangle, so we got to use a trig function. So when we use a trig function, we have to establish a reference angle. So I'm going to use the 7-degree angle. That should be 7 degree as my reference angle. So now I'm going to label all of my sides according to the reference angle. So my hypotenuse is opposite the right angle. The side for the height of the building is opposite my reference angle. So H is actually my opposite side. So the base of that angle of elevation, that's my adjacent side. So what trig function could I set up to find H? Well, I have to use the opposite because that's what I'm trying to find. I know the adjacent, and I know my angle measurement. So the opposite over the adjacent is what type of trig function? Tangent, right, from the Chief SOHCAHTOA. So I'm going to set up a tangent function. So we're trying to find the h, which is the height of the building. So the tangent of 7 degrees, that's equal to the opposite, which is h, over the adjacent, which is 2 miles. So now how do I solve it for h? Well, I just multiply both sides by 2. So 2 times the tangent of 7 degrees is equal to h. So I'm going to evaluate the tangent of 7 degrees in the calculator and multiply that by 2. Okay. So now one thing about my calculator is that I always have to check that I'm in the right mode, because this calculator that I'm using on the computer, it'll like do its own thing. So I have to check to make sure I'm in radian or degree mode. The only way it'll change on your calculator is if you physically change it. Okay? But you'll see me check this because sometimes it'll just flip everything to the left and I can be in radian mode when I thought I was in degree mode. So I'm in degree mode. All right, so I'm going to put in 2 times the tangent of 7 degrees. And I get 0.24. But notice that's not my answer. Why don't I get the right answer? That's because that 0.245 is in miles. They want the answer in feet. So we got to convert. So if you just remember back to conversions, 5,280 feet is equal to 1 mile. So I want to convert 0.245 miles to feet. How do I do that? Well, I can use something called a unit fraction. Let me just explain the unit fraction. Okay, I have 0.245 miles. I'm going to multiply that by a unit fraction. A unit fraction is a special form of 1, right? Anything over itself is 1. Since I want to convert from mile to feet, I'm going to put miles in the denominator, and I'm going to put feet in the numerator. So that way, when I multiply the 2, my miles are going to do what? Cancel, and I'm left with feet. So then I'm going to put my conversion. 1 mile is 5,280 feet. So that's a special form of 1, because anything over itself is a 1. So when I multiply the 2 together, the miles cancel. So if I take that number 0.245 and multiply that by 5,280, right? That should give me the equivalent in feet. So on my calculator, I'm going to multiply that 0.2455 by 5,280. And if we round to the nearest foots, right, because it says find the height to the nearest foot, we get 1,297 feet. So we had to convert miles to feet. Any questions about that? All right, now there's a couple of problems at the start of it. Number 1 and number 2, they tell you to find cofunctions. So there's actually some formulas for that. Okay, let me just close those down, close that down. The co-function formulas are not found on the formula sheet. The co-function formulas are found in the lecture notes. I think it's 8 point. I thought they were somewhere on here. Okay, let me just write them down. Okay, instead of just writing them down, I just went to Google and I put in co-functions. So here are the co-function formulas. It says the sine of 90 degrees minus theta is equal to the cosine of theta. The cosine of 90 degrees minus theta. So theta is the angle that you're given. That's equal to the sine of theta. And the tangent of 90 degrees minus theta is equal to the cotangent of theta. And then these are the co-functions in reverse. Right? The cosecant of 90 degrees minus theta is equal to the secant of theta. Secant of 90 degrees minus theta is equal to cosecant of theta. And the cotangent of 90 degrees minus theta is equal to the tangent of theta. And then there are these alternative formulas. Right? If you're given degree measures, you will use the degree set of formulas. If you're given a radian measure, because like pi over 2, that's still 90 degrees, right? But it's just pi over 2 radians. These are the equivalent formulas given in radian measure. So let's just see how they work. Okay, I'm gonna try to let that stay up. Okay, I was trying to put these things side by side, but okay. So this first number. This is the first one. It says use the cofunction of complementary angles. So complementary just means the sum of two angles whose measure is 90 degrees. It says the sine of 52 degrees is equal to the cosine of blank degrees. So since I'm dealing with angle measures in degrees, I'm going to use this first form. It says the sine of 90 degrees minus theta. I'm going to substitute theta with 52. That's equal to the cosine of theta. And I'm going to do that on the board. Find a cofunction. The sine of 52 degrees is equal to the cosine of blank degrees. So I'm going to use that first formula. The sine of 90 degrees minus theta. I'm sorry, this is 52. So what's 90 minus 52? So that's 8 will be 40, no, 60. Is it 38 degrees? All right. So that's where I get 38 from. I just use this first formula. I substituted theta for 52. And then these things are equal. If you were to put this in the calculator, just to show that, okay, I have to make sure I'm in degree mode. The sine of 52 degrees should equal to the same thing as the cosine of 38 degrees. So that's number one. The second one, I believe I'm giving angle measures. I'm giving radian measure. So it says the sine of 1/3 pi is equal to the cosine of blank. So 1/3 pi, that's going to be pi over 3. So I'm going to use this formula because I'm giving radians. So the sine of pi over 2 minus pi over 3. So now in order to subtract fractions, you need a common what? Denominator. The least common denominator and the least common multiple are the same. So this is what multiples are. So the multiples of 2 are 2, 4, 6, 8. That's going to keep on going, right? The multiples of 3 are 3, 6, 9, 12. That's going to keep on going. What's the least common multiple? 6. So I'm going to change my denominators to 6. So now I got to make equivalent fractions. This 3 was multiplied by what to give you 6? Excuse me, this 2 was multiplied by what to give you 6? 3, you got to multiply the top by that same 3. For the second fraction, 3 was multiplied by what to give us the least common denominator? 2, we got to multiply the top by 2. Right. Well, really, I just want the answer for this. So now when you combine fractions, you got to have a common denominator. So I'm going to keep it as 6. I'm not going to add them or anything. I'm going to combine my numerators. So 3 pi minus 2 pi is what? Pi. And I keep my denominator 6. So the answer here should be pi over 6. So the sine of pi over 3, and if I put that in the calculator, they should check out. Let me change my mode to radian. The sine of pi over 3 is the same as the cosine of pi over 6. So you get the exact same